All right, I want to finish the rest of this on this side. So we'll go over here to 3. So that's going to equal VC, our infusion time is going to be VC over F, right? So our flow rate is going to be, or let's start out with our volume. What's our volume going to be? Well, it's got to come back over here, right, to the 1,000 milliliters. And our calibration, we don't have, right? So that stays out. And our flow is going to be what? 120 milliliters per hour. What cancels? Milliliters. This is going to equal how many hours? All right, 8.3 hours of infusion time. Does that make sense? This one's a little more involved. Everybody set? bag of 9% NS is infusing at a rate of 20 drops per minute. The infusion set is calibrated to a drop factor of 15 drops per milliliter. How many milliliters of the solution will be infused in an 8-hour shift? Okay. What are we trying to find here? Or, yeah, milliliters, which is volume, right? We're looking for volume this time. Our original equation was this, right? So if we're looking for volume, what are we going to get? Right? So we're looking for volume. First thing we should do is what? Because our time is in what? Minutes or hours? No, in our equation. Yeah, because this T is time in minutes, right? If you remember from the first board. So the first thing we should do is change this 8-hour shift to minutes. That's what we're looking for. Or that's what we need for the equation, I should say. So an 8-hour shift is, so we'll say convert hours to minutes. All right, so we got an 8-hour shift, so this is 8 hours. I use dimensional analysis, 1 hour is 60 minutes. In this situation, the hours cancel, we're left with minutes. 8 times 60 is going to be 480 minutes. So we're going to use that in our equation. Now, for step 2, let us take the equation we used to solve for volume, and let's solve for that. So it's going to be V is Ft over C. So let's identify our variables on this board here. The time is going to be what? We just calculated that out. 480 minutes. What is our calibration going to be?
15 drops per milliliter.
This is our C right here, right? So the calibration is going to be 15 drops per milliliter. And then our F is going to be what? It's being infused at what?
20 drops per minute.
Yeah, 20 drops per minute. So here we're defining all of our variables. Over here we'll solve the, plug it in and solve the equation. All right, so let's solve for this. So our F, which we already said, is 20 drops per minute, times our T, which is 480 minutes, and our calibration is going to be 15 drops per milliliter. All right, what's going to cancel? Drops are going to cancel because we've got them here in the numerator and here in the denominator. What else is going to cancel? Minutes, because we got minutes here in the denominator and minutes here in the numerator, so those cancel. So what are you going to be left with? Milliliters, which is a unit of volume, which is what we're looking for, right? So that's, sounds like it makes sense. All right, so let's take 20 times 480 and then divide that by 15, and we're going to get 650? 640. So it's going to be 640 milliliters. So that's the volume to be infused. Did everybody get 640? Okay. Sounds good. All right, makes sense?